How's it going, guys, and welcome back. My name is Jake Johnson, and today we're going to be starting our first part of a sort of playlist, I guess, for the upcoming exam, of course. And so for this one, we're going to be starting to talk about the evolution of sex. More importantly, we're going to be talking about the natural selection, the components of that, and the difference from natural selection and evolution. A few things before we start this lecture off. I'd like to first go back to my original videos. I have gotten many emails from you guys, and thank you so much for those. And one of the things is that no, my PowerPoints are not comprehensive. Meaning, yes, it will help you memorize the system and such. However, in order to do well in an exam, or for really in order to understand the process fully, you're going to have to do a lot of external, studying and such, and trying to understand, what each part of the things do, and how that affects different developmental stages and such. So just sort of think of my PowerPoints as sort of like a tool. So you can see it as memorizing the system, so the order of things, everything else. As for how everything works, that's going to rely heavily on you. Now, if there's anything you'd like me to help with in that process, feel free to drop me an email or put it in one of the comments below, and I'll try to make a video on that the best I can. However, it is going to be very based on your guys' contribution to your own studies. So without further ado, let's go ahead and start this lecture off. Okay, so before we get really into the depth of this, we first have to go over what the difference is between a genotype and a phenotype. So as you can see in this little graphic right here, we have our genotype and we have our phenotype. So the genotype is going to be the actual genetic code. So this whole thing of A's, C's, G's, and T's, and that's going to be your male and female, so that's going to be from your father and mother, and then that's going to code for your genotype. So in this example, it would be EE would be the genotype. And then genotype is actually going to code for a phenotype. The phenotype is going to be the actual trait expressed. And this trait expressed in this example is going to be an ear face. So as long as you guys can get this graphic, we can go further into so natural selection. There's going to be 3 different requirements, and I know you guys have already learned this in class, but I like to go over the standard definition of things before we go any further in things. So the 3 requirements are going to be variation, heritability, and differential reproduction. Now, I know you guys already know all the definitions. You're like, okay, Jake, I know the definitions already, or maybe if you don't know the definitions already, well, here they are. You can kind of see, difference in phenotypical traits, like, yeah, okay, Jake, I get it, it's sort of, it's not too hard to read, but, one of the things I have noticed that, yeah, you guys can, repeat the definition of things, but you guys can't really apply the things to a real life situation. So because of that, I like to do one myself. So this is going to be, from here on, is just going to be sort of like an example of each of these different segments of the natural selection. So of course, starting off with variation. So variation is just going to be a difference in phenotype. So as you can see here, we have Mr. Ear. Now Mr. Ear, he has a gene called the ear gene. Okay, this isn't a real gene anyway, guys, so this is just for point of example, so I don't need to get a lot of emails saying, this is a real gene, Jake. As I hope you guys can tell. But anyways, so this guy has this gene, and it expresses as him having an ear face. And this is different from, the average population, as you can probably tell, hopefully. Because, most people do not have this trait. So this variation is the variation of him having a huge ear for a face as opposed to other people not. Alright. Now, heritability. Heritability is the ability for this phenotype to be passed on. Now, I just thought this picture was really cute, so I just decided to add that in there too. But it does play a purpose in the thinking of, how a phenotype can get passed on from one generation to the other. So that's just something I want you guys to think about there. Alright, so differential reproduction. What this is, as you guys can tell from the previous definition, this is going to be the difference in offspring based purely on the phenotypical traits alone. So let's imagine we have Ear Guy over here, and we're going to be comparing him to none other than Jake Gyllenhaal. So as you can tell, you know, one in our culture is probably going to be a little bit more attractive than the other. So let's just go look at that in a little map. Okay, so right here, this is going to be this little map of all the different samples. So over here on the left, you're going to see your little ear guy sample. Over here on the right, you're going to see your Jake Gyllenhaal sample. And right here in the middle, you're going to see your women's sample. So as you guys could probably predict, the women are going to want to go over to Jake Gyllenhaal. The reason for that, because on planet Earth, most women find Jake Gyllenhaal to be a lot more attractive than Mr. Ear Guy. Even though there may be a few exceptions, but for this example, all the women choose to mate with the Jake Gyllenhaal. And of course, when you mate with the Jake Gyllenhaal, he's going to pass on the Jake Gyllenhaal gene, and all of his kids are going to be little mini Jake Gyllenhaals. As for the ear guy, he's going to pass on no offspring because none of the women decided to mate with him, so none of his phenotypical traits will be passed on. Alright, so let's imagine we have an environment change. So let's say both of these samples right here were transported to a different world where it's just filled with ear people, particularly ear girls. And these ear girls are going to find the trait to have an ear face to be really attractive. So of course, as you guys could probably tell, the ear girls are going to want to mate with the ear guy. And furthermore, the ear guy and the ear girl are going to have offspring that passes on their trait to have little ear babies, and they're going to have the little ear trait right there, and it's so cute. But anyways, and of course, since it's all with ear people and they don't find the Jake Gyllenhaal trait to be very attractive, the Jake Gyllenhaal trait is then going to be selected against, and you're not going to have any more Jake Gyllenhaals. Okay, so now that we're done talking about natural selection, it's time to talk about the concept of evolution. Alright, so what evolution is simply just the change of genotypes over time in a given sample or population. So to better visualize this, you can see in this diagram where you can see our familiar table with the Earman sample and Jake Gyllenhaal sample. So as you can see in this graphic right here, all the women are going to be the ear girls. There are going to be a few exceptions, of course, because the norm would be the ear girl going with the ear man. However, as you can see right here, there's that one exception where the ear girl decided to go with the Jake Gyllenhaal man. So this is just for a point of, you know, how not every system is perfect. But anyways, as you can see here, just for sake of simplicity, we're starting off with the male population being 50% males that have the Earman gene and 50% that have the Jake Gyllenhaal gene. And with time, and as you can see in the offspring right here, you'll end up with 83% of the Earman gene and 17% of the Jake Gyllenhaal gene after selection. So that's just 1 out of 6 for the Jake Gyllenhaal gene and 5 out of 6 with the Earman gene. So and this whole thing right here is going to be evolution. So it's a change of genotype over time. Alright, and that concludes this presentation. I'm sorry it took so long for this video to come out. I've just been really busy with work and school and everything. However, I do hope to finish all the rest of the topics on the study guide before the exam, which doesn't leave me much time, but I'm going to try my best, guys. So if you guys would like to see any other videos, please sure to leave a comment in the description or send me an email with the video you'd like to see. And I'll see you next time. Thanks a lot, guys. See you later. Alright, bye-bye.